Hello everyone, welcome back. In this video, we're going to begin our discussion of the C++ vector. Let's head over to the notes. Vectors are like arrays, so our first learning objective for this lesson is to compare arrays to vectors and see the advantages that vectors can bring. We're also going to learn about something called the standard template library, which includes the vector type. Then we're going to learn how we can initialize and index vectors to perform some basic operations using vectors. So for our warm-up task, let's go ahead and open a file called vectorfun.cpp and get an empty main function ready for us so we can write some vector code. Let's first talk about the STL. The STL is called the Standard Template Library, and it's a collection of data types and algorithms that you can use in your program. This kind of comes back to the idea of don't reinvent the wheel. There are lots of problems that can be solved using standard data types and standard algorithms, and this library, the STL, is a collection of implementations of those data types and those algorithms that you can reuse over and over and over again in your programs. Just like how we use the C math library in order to gain access to standard math functions, we'll use the STL in order to gain access to standard data types and algorithms. Particularly in this class, we're going to use the vector data type, which is a powerful array-like data structure that we can use from the STL. Let's talk about vectors and how they are like and unlike arrays. They are like arrays in that their definition is nearly the same. They store a sequence of the same type of items contiguously in memory. What's different about vectors than arrays is they are more powerful and more safe to use. For example, vectors can grow or shrink in size. When we've been declaring arrays to be just big enough or bigger than we need in order to solve our problems. Because after we declare an array, we cannot come back and try to make that array larger or smaller. It's fixed in size. That is not true for vectors. Vectors can grow or shrink, so we might initialize a vector to be empty and then add items to our vector as needed when solving our problems. Vectors also have something called member functions, which do really useful vector operations. For example, just like with strings, how we can get the number of characters in a string using size, or we can index into a string using @, we can use those same member functions for vectors in order to get the number of items in the vector and how to get an item at a certain index location in the vector. We're going to have an entire video dedicated to vector member functions, so I'll describe in more detail what makes a function a member function and what are some example vector member functions we can use at a later time. Lastly, I said that vectors are safer to use than arrays. One reason why is they have built-in bounds checking, which means if you try to index into a vector at a value, an index position that is out of bounds, for example, at n or n+1, where n is the number of items in the vector, this will actually cause an exception to be thrown instead of allowing your program to access memory that doesn't belong to that array. So that makes vectors more safe to use. All right, we are now ready to write some code related to vectors. In order to use the vector data type, we've got to #include the vector library or the vector header file, and then we can use the vector data type to declare a vector. To declare a vector, we'll use the name vector, and then these angle brackets that look like the angle brackets we use for using a standard library in our pound include statements. Inside of the angle brackets, we'll put the data type of that vector. For example, here, there's a variable called myInts, which is a vector of integers. That's how you can read this. If you want, when you declare a vector, you can put parentheses after the variable name, and in the parentheses, put the size of the vector. But remember, vectors can grow and shrink in size. So this is just a starting size. Your vector could get smaller or larger depending on what operations you perform on it. All right, let's head over to vectorfun.cpp. We're going to include the vector library. And while we're here, let's also include the string library. Now let's go through a little bit of code to declare vectors. Let's say we're going to have a vector of int called myInts. Since we didn't put a size after myInts in parentheses, this is an empty vector that is ready to store integers. Let's do a vector of strings now, and let's have my strings, but this time we'll put in a number here such that we have a vector that stores 10 empty strings. So we haven't initialized these strings to be anything in the myStrings vector, but there are 10 placeholders to store those strings when we're ready to assign values to them. Now, we can also initialize vectors at the same time we declare them. For example, let's stick with a vector of strings. And let's have a vector of strings called words. We can initialize words to be, let's say, 5 hellos. We could also use curly braces and state exactly what strings we want to initialize our vector to be. For example, maybe I'll put in here, hello, goodbye. Now this is a vector that stores 2 strings where the first string is initialized to hello and the second string is initialized to goodbye. We can go ahead and save, compile, and test our vectorfun.cpp. There's no cout statements, so we're not going to see anything occur. Next thing we want to do is add some cout statements in order to print out individual elements or items in the vector. So one thing to note, and I've mentioned this previously, vectors, unlike arrays, will not allow you to access an element using an invalid index. If your index is out of bounds, this will actually cause an exception to be thrown in your program. And we'll see that here shortly. So if we want to grab an individual element from a vector, we can use the subscript operator, which is the notation hard brackets, or we can use the @member function. So let's see out words 2 at element 0. And let's see out words 2 at element 1, but this time we'll use the @member function. And we see hello, goodbye. Now let's see what happens when we change our indices to be invalid. For example, let's say we change the 1 to be 100, which we know is out of bounds. There are only 2 strings in words 2, so only indices 0 and 1 are valid. So if I do this, I get terminate called after throwing an instance of out of range. What happened? There was a range check. 100 is greater than the size, which is 2. So this crashes our program. But at least we get this really nice error message that tells us exactly what happened. And in the future, you'll be able to write code that can handle this kind of exception or this kind of error occurring so that it doesn't crash your program. But for now, in 121, this is going to crash our program. So I'm going to put this back to 1. And note the benefits of using the member function at, because there's bounds checking that occurs so that you can't have a logic error where you accidentally are using memory out of bounds. Instead, you'll get this runtime error, which is much easier to debug. However, let's say I do 100 using the subscript notation brackets, and let's see what happens. It looks like we just get an empty string here. So the moral of this lesson is you want to use at over the hard brackets when indexing into a vector, because at performs that bound checking, which will give you a runtime error, whereas the hard bracket notation operator does not perform the bounds checking and will give you a logic error instead. So let's make a little note about that. Great. Now let's move on to a next topic related to vectors. Use the size member function in order to get the number of elements in the vector. So for example, let's print out the size of all of our vectors. We'll do myInts. We'll also do myStrings. And we'll do words and words too. Okay, the size of myInts is 0, which makes sense. We declared it to be an empty vector and we haven't added anything to it. MyString size is 10, which makes sense. We initialize it to 10 and haven't added or removed anything from it. Words.size is 5, which makes sense because we initialized it to 5 hellos, which we also haven't added or removed any strings from. And then lastly, words2.size is 2, which we already knew that because of the message we got when our program crashed. It said that the size of our vector is 2. Awesome. So we can use the size member function and at member function in order to write a function that can print out each element in a vector. So let's do that. Let's have a print vector function which accepts a vector of string. And we don't need to pass in a size because we can now get that from the vector variable itself using the size member function. So we can use a simple for loop in order to iterate over each string in our vector. I think I'll make mine just space separated to save on space in the output, and then just put a new line at the end. So I'm going to print out words and words 2. And there are my 5 hellos from words, and there's my hello goodbye from words 2. Our last big topic of this lesson is related to multidimensional vectors. Just like how we can have 2D, 3D, or ND vectors, arrays, we can also have 2D, 3D, 4D, ND vectors. So in order to declare a multidimensional vector, such as a 2D vector, you'll have to nest the vector type, which makes sense once you see an example. So let's take a look at this code here. Here I have a vector whose data type is a vector of strings. So you can see this inner vector is nested as the data type of the outer vector. Let's code up an example. So let's have a vector where each item in the vector is also a vector, and each item in the inner vector is a string. And we can call this 2D words, for example, if we want. So this would be an empty 2D vector of strings. Now let's declare another 2D vector. We'll call it 2D words 2. And here we can use the curly braces in order to initialize the strings in our 2D vector at the same time we declare them. So let's say my first vector should have the strings 1 and 2, and the second vector in our vector should have the strings 3 and 4. Go ahead and save, compile, and test this, but there won't be any output related to our 2D vectors because we haven't used them. We've just declared them. So let's write another function, and we'll call this one print 2D vector. The data type coming in for this parameter will be a vector of strings. Just like when we print out a two-dimensional array, we have a nested loop. Our outer loop is driven by a loop control variable I, and our inner loop is driven by a loop control variable j. We can solve a printing 2D vector problem the same way. We'll have I and j. I will walk through each element in the outer vector, the 2D vector, which is itself a vector. So our inner for loop will walk j from 0 to the size of the inner vector. But if I do v.size, this is referring to the size of the outer vector, not the inner vector at position I. So to make things clear, we can do one of two things. We can index at I from v to get the vector at position I, and then take the size of that. Or we could declare a temporary vector and use that in order to get a reference to the vector at I. And then instead of having this v.at_i.size, which can look a little bit crazy, we could instead just use temp.size. Either one of those approaches works. I'll do the same thing, space separated within a row, and then each row will be separated by a new line. And there I have my output of 2D words 2, which we initialized to 1, 2 in the first vector and 3, 4 in the second vector. Some last things to show you related to vectors include what happens if you just try to print out a vector directly. We know what happens if we just try to print out an array directly. We'll get the memory address of the first item in the array. Let's see what we get if we print out a vector. Let's print out the vector words. We actually get this crazy output here. It's a compiler error. And there's so many errors here. Wow. So we always want to look at the first one. It says, line 40, no match for operator, which is our stream insertion operator, the two less thans. Operand types are ostream, so that would be cout, and vector. So it's saying this operator doesn't have support for essentially the operand vector and the operand ostream. But we know there's support for ostream, so the problem must be with vector. So essentially, we can't print out the words or the words 2 or the 2D words 2 or 2D words variables because they're vectors. We'll have to use our print functions, which is one of the reasons why we wrote those. So same thing kind of applies then for vectors and arrays. We can't simply see the contents of the vector or array by printing out the variable related to the vector or the array. We'll have to use for loops or some sort of looping structure. And typically we'll put those looping structures in functions like we did for print 2D vector and print vector. All right, that wraps up our introduction to vectors. In the next video, we're going to talk more about vector member functions and really just the idea of member functions in general. Why do I keep calling them member functions instead of just functions?